Welcome everyone. I want to take you through a brief tutorial now to see how images are delayed when we use Simulink versus when we use code generation. I want to point out that this is an extension of the image acquisition tutorial, except that now we're actually producing an image as well. So we're consuming images from the left camera on the cat vehicle, and we're converting those into a MATLAB image. Then we're converting that into a grayscale image and converting it then back to a raw ROS image and producing it out under the topic camera left grayscale. I want to begin by just running this in, let me make sure this isn't running anymore over here. I want to run by just, start this by just running the MATLAB model. So I'm going to press play here, and it's going to compile my model and produce all the updated outputs so that we can run directly from within Simulink. What this will do is it will produce this image that pops out here on the right, and I can actually view that image here from RViz. So I have two different images that I've thrown up on my screen. One of them is from Gazebo, we can see that here. The other is from Simulink, and the one from Simulink you can see subscribes to /catvehicle/camera left grayscale. And so that topic, again, these are both raw images. So I'm playing this video now, and we should expect that if we make the car move around that we'll see this image, which is directly from ROS run, directly captured from Gazebo, as well as see this image collected directly from Simulink. But we're running Simulink in situ now, so Simulink is running and we're ready to go. So I'm going to press on this open loop, I'm going to run the hard left drive here, and we're going to see these two images happen. So we can clearly see here that on the right, the image directly from Simulink, or directly from Gazebo, is executing much smoother and essentially with almost no latency compared to what we saw there from the other side. And it also looks like the car itself is behaving kind of irrationally. I might try to run this again. Actually, what I'm going to do is I'm going to kill it here, because it looks like we've either come close to colliding with an obstacle or collided with an obstacle, so the car's not going to move anymore. But what I wanted to point out was that we have some delay, and that delay in large part is introduced by the fact that that Simulink is having to run in the background, and it's having to do a lot of stuff in order to show how it should behave. So this was really evident in the original tutorial, where we saw that the raw image, if we wanted to show it inside of Simulink, had a tremendous amount of delay. And so if you've seen that video, you thought probably, wow, why would I ever use Simulink in order to do that? Well, one of the reasons that you use Simulink is to figure out how to prototype your algorithms, but then when you want to deploy them, you'd like to take advantage of code generation. And so if you come up here to code, C++, build model, you can produce a C++ version of this code that will run much more effectively than the version that you saw running natively in Simulink. So let me start up the cat vehicle program again here, and every once in a while there's another package that didn't stop, so I had to Control-C this and then bring it back up. Control-C, C, we're going to kill this. Alright, so now we're ready to run it again, and we still have some red stuff, so I need to do one of these kill -9 kind of things, which is never really fun to do. But you have to do it every once in a while. So I don't think I have anything else running here. PSAUX, grab GZ. Looks like I don't have anything running, so we'll try this one more time to run. And I think now all those zombie processes are gone, so we should see that Gazebo should be loading just fine. And while Gazebo loads, I'm going to go ahead and run RViz so that we can visualize our image again. So here again, this image, once Gazebo comes up, we should see an image here that comes directly from, let's rename this one. This image is image from Gazebo. We can see that here. And then this image we should get from the camera left grayscale. So this isn't showing up yet. And the reason that it's not showing up yet is because we haven't started the code generated node. So now I compiled all that code, and I was able to produce this output in the source directory here for image delay. So ROS run image delay node. So now the image delay node should be running, which means we should be able to subscribe to it here. And it's really unhappy. So let's remove this and then add a new one. By topic, camera left, grayscale image. Okay, good. So now we have this image here, which I'm going to rename. Instead of just plain image, let's rename this as image from Simulink. And again, we're running the generated Simulink code here. We're not running the code through Simulink itself. So let's do the same thing that we did before and run the hard left turn. And now we can see that even though there's some lag and delay here, that we're able to keep up fairly well with the data that are coming directly out of Gazebo. So if you want to take advantage of Simulink at runtime, it's much more effective to produce the generated code and then use that generated code as your runtime engine. Now you're obviously going to be able to save even a little bit more time by not producing an image as the output. So what you're going to be producing in many cases is a classification of pixels where you think you found a necessary object, or you might even just be using Simulink in order to gather data so that you could classify objects, so that you could decide how to correlate data from the laser scanner with data that comes from an image. So many of the things that you're going to be doing are going to involve using Simulink or MATLAB in your prototyping workflow, and then once you've got an algorithm put together, you're going to be generating the code and then running the code natively. So hopefully this tutorial shows you some of the advantages of using code generation, and I look forward to your comments. Thank you.